Some of you have heard the quadratic formula, but it's something that everyone here is going to have to memorize at some point, starting actually now, so this is a good time for us to do it. Anyway, what we need to know is that the quadratic formula is another way to solve something of the form ax squared plus bx plus c is equal to 0. Usually what we do when we end up with something like that is factor, but if I had something like x squared plus 5x plus 1 equals 0, I can't factor that, and we need another way to solve for x. That other way is the quadratic formula. So what I want you to write down specifically is that this works when you have ax squared plus bx plus c equals 0. I know you're writing that down right underneath it, but this is important. You need to have it in this form, descending order, in order to figure out what it is, and also equal to 0. The solutions of a quadratic equation in the form ax squared plus bx plus c equals 0, where equals 0, are given by this. So, somewhere in kind of white space or off to the right or whatever, or just flip it around, once you write this kind of written out, x equals opposite of b. Some of you, especially the Creeksiders, would have learned negative b, but that's not quite correct. Plus or minus square root of b squared minus 4 times a times c. Actually, I'll just make this 4 an actual 4. All over 2a. So for our first problem, I want you to practice writing this. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. We're going to practice writing this several times. And then the next thing is to take the equation and set it equal to 0. 4m squared plus 3m minus 1 equals 0. If I compare that to the quadratic form of an equation, ax squared plus bx plus c, I can see, okay, ax squared plus bx plus c equals 0. I can see from this I can pull apart a must be 4, b must be 3, and c has to be negative 1. I'm going to write that off to the left side. A equals 4, b equals 3, c equals negative 1. Now it's simply a matter of substitution. X is equal to the opposite of b was 3, plus or minus the square root of b squared is 3 squared, minus 4 times a is 4, c is negative 1, then all over 2 times a. And simplify. X is equal to opposite of 3 plus or minus the square root of 3 squared is 9, negative 4 times 4 times negative 1 is positive 16, so 9 plus 16, then all over 2 times 4 is 8. So then we have negative 3 plus or minus the square root of 9 plus 16 is 25 over 8. Square root of 25 is 5, so then we have negative 3 plus or minus 5 over 8. Now, plus or minus means two possibilities, so we have negative 3 plus 5 over 8, and then we have negative 3 minus 5 over 8. And those give us our two possibilities, two answers. Negative 3 plus 5 is positive 2, so then I have 2 over 8. Negative 3 minus 5 is negative 8 over 8. And we have 1/4 and negative 1. Then I'll bring that back to our solutions of negative 1 and 1/4 in set notation. For number 2, if I kind of look at this, create a little bar to separate that, we have coefficients of 1, negative 5, and 2. And I'm going to say a equals 1, b equals negative 5, and c equals 2. X is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And let's substitute now. X is equal to opposite of negative 5 plus or minus the square root of negative 5 squared in parentheses minus 4 times 1 times 2 all over 2 times 1. Next, let's simplify. The opposite of negative 5 is positive 5, plus or minus the square root of negative 5 quantity squared is 25, minus 4 times 1 times 2 is minus 8, all over 2. And I have 5 plus or minus the square root of 17 over 2. And that can't be simplified. Radical 17 is an irrational number, so we're going to leave it like that. It represents two possibilities, 5 plus or minus radical 17 all over 2. Number 3, if we set it equal to 0, we get k squared plus 4k minus 1 equals 0. Look at the coefficients. The coefficient of the square term is 1, so a equals 1. The coefficient of the linear term, the k, is 4, b equals 4. And the coefficient of the constant term, or the constant term actually is negative 1. We say, in this case it's not x equals, it's actually k equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Do some substitution. Opposite of b is opposite of 4, negative 4, plus or minus the square root of 4 squared minus 4 times 1 times negative 1, then all over 2 times 1. It's essential you show that substitution step, especially in the early parts of this, to make sure you get everything in the right place. And now we take another step and simplify. Negative 4 plus or minus the square root of 16. Negative 4 times negative 1 is positive 4 all over 2. That simplifies to negative k plus or minus, or negative 4 plus or minus radical 20 over 2. And you should recall from before that radical 20 can be simplified itself. Radical 20 is made up of 4 times 5, and that would actually give me the square root of 4 is 2, so then I have negative 4 plus or minus 2 radical 5 over 2. Now if I look at the numerator, I can factor a greatest common factor out of negative 4 and 2 radical 5. I'm going to pull a 2 out to get negative 2 plus or minus plus or minus radical 5 over 2. Then we can divide 2 by 2 or cancel, and I have negative 2 plus or minus radical 5. For the next one, if I look at the coefficients, I have a equals 3, b equals 2, c equals negative 3. And I do y is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Do some substitution. Y is equal to the opposite of 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 3 over 2 times 3. So we have negative 2 plus or minus the square root of 4. 4 times 3 times 3 is 12 times 3, or 36. So 4 plus 36 all over 6. And then I have negative 2 plus or minus square root of 40 over 6. 40 is 4 and 10, so this simplifies to 2 plus or minus 2 radical 10 over 6. Factor a 2 out, and I get 1 plus or minus 1 radical 10 over 6. And it's the 2 and the 6 we cancel out. Remember, we can only cancel after we factor. 1 plus or minus root 10 all over 3. We'll put that set notation. There we go. Number 5, we need to set it equal to 0. 2x squared minus 9x minus 3 equals 0. A is equal to 2, b is equal to negative 9, c is equal to negative 3. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we have the opposite of negative 9, which is positive 9, plus or minus the square root of. Now, I'm going to give you a little trick here. When you have your b squared and it's negative, you don't have to write it as negative. In fact, I wouldn't. I would put 9 squared, because negative 9 squared is positive 81 as well. But this way you're not going to mess up where the negative goes. Minus 4 times 2 times negative 3 all over, get that line going. Let's draw a better bar. 2 times a. x equals 9 plus or minus square root of 81. 4 times 2 is 8, times 3 is 24. It's a plus 24 all over 4. I have x is equal to 9 plus or minus the square root of 105 over 4. Got to check 105. It's divisible by 3. So I'm going to go 3 into 105. And that gives me 3 times 3 is 9. 1, 5. Okay, 35 and 3. 35 is 7 and 5. Okay, so that's not going to simplify. And that's done. I'm going to erase the x equals and just make it set notation. For 6, a is equal to 3, b is equal to 5, c is equal to positive 11. That should be kind of fairly obvious. Coefficients of the square term, the linear term, and the constant term. D equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. D equals opposite of 5 plus or minus the square root of 5 squared minus 4 times 3 times 11 all over 2 times 3. D equals opposite of 5 plus or minus the square root of 25 minus 12 times 11 is 132 all over 6. That simplifies D equals opposite of 5 plus or minus the square root of 25 minus 132 is negative 107. Is that right? Yes. All over 6. And we have a red flag. We cannot take the square root of a negative number yet. We are solving these in the real numbers. Square root of a negative number is what we call an imaginary number, and we will get to those in the second year. But for now, because we're saying to solve these under the real numbers, what we get to say is there's no real solution. And think of that as like a to be continued. Square root of a negative number is an imaginary number, and a number that contains an imaginary number is called a complex number. Let's go to number 7. You got fractions. Do not do these with fractions. That's not the best way to do it. Let's just multiply the left and the right side of the equal sign by a least common denominator. 3 and 2 makes it 6. And if I multiply using the distributive property with 6, I would get 6x squared minus 4x minus 9 is equal to 0. Then I can set my a equals 6, b equals negative 4, and c equals negative 9, and solve it that way. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We said the 3 most important things of the freshman year are the ratio, substitution, and order of operations. This contains all 3 of those. Substitution means we plug our opposite of negative 4 is positive 4 plus or minus. Remember I said drop the negative and just make it 4 squared minus 4 times 6 times negative 9 all over 2 times 6. Just to kind of give you a little highlight match. This is this and this. This goes here and here. And this went here. Okay. X equals, I don't like the color. Don't like that color either. Sorry, I'm just trying to have fun with this. X equals 4 plus or minus the square root of 16. We have 2 negatives, make a positive. 24 times 9, or 36 times 6 might be easier. 216 over 12. And I have x is equal to 4 plus or minus square root of, this would be 232 over 12. 232, I know I can at least take a 4 out of that because the last 2 digits. So 4 out of 232 is, that would be 58. And 58 is 29 and 2. So really what I'm going to end up with is x is equal to 4 plus or minus. Since 232 is 4 and 58, this is going to be 2 radical 58 over 12. Take out a greatest common factor out of the numerator, and I have 2 times 2 plus or minus radical 58 over 12, and cancel those out to get a 6. X is equal to 2 plus or minus radical 58 all over 6. Erase that, set notation, let's move on. There's another one with fractions. Let's clear the fractions. Multiply the left and the right side of the equal sign by a least common denominator. 4 and 2 gives me 12. And I end up with 12x squared minus 4 times 7 is 28x equals 3, or 12x squared minus 28x minus 3 equals 0. Then we do x is equal to opposite of b plus or minus the square root of b squared minus 4ac over 2a, where a is equal to 12, b is equal to negative 28, and c is equal to negative 3. So with x equals opposite of negative 28 plus or minus the square root of 28 squared is 28 times 28. 8 times 8 is 64. I never used the lattice method when I divided, so sorry for those, or multiplied, sorry for those of you who use it. This is ours. Let's see, 8 times 2 is 6. 1, 5, add 4, 8, 784.
The area of the circle, I wouldn't use that. I mean, the circle radius.
Minus 4 times a, 12, times c is negative 3, all over, this would be 2 times 12. Let's extend that out. X equals 28 plus or minus square root of 784 minus 48 times 3 is 96, 144. That's 12 times 12, so yes, plus 144. Oops. All over 24. X equals 28 plus or minus the square root of, this would be 928 over 24. Let's take 928 divided by 4. You get 232. Let's take 232 and divide it by 4. And I get 58 because I did that before. So really what it comes down to is 928 is 16 times 58. So I get x is equal to 28 plus or minus 4 radical 58 over 24. And in the numerator I can take out a 4, giving me 7 plus or minus radical. That's a terrible radical. That's a better radical. 58 over 24. And cancel the 4 and the 24 to get 6. So then my final is 7 plus or minus radical 58 all over 6. Next problem. Okay, so this one I actually need to simplify first by squaring this. Don't kill puppies. Square the binomial correctly. Remember this image. Don't kill the puppies. X squared minus 4x plus 4 equals 3x minus 5. Subtract x squared minus 7x to be plus 9 equals 0. And then let's do the quadratic formula. A equals 1, b equals negative 7, c is equal to 9. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c. Oops, I'm starting to plug it in. Gotta write it one more time. All over 2a. X equals opposite of negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 9 all over 2 times 1. X equals 7 plus or minus square root of 49 minus 36 over 2. We have x is equal to 7 plus or minus the square root of 13 over 2. We're done with that one. One more. I think one more. Yep, one more. Sorry, it's a longer lesson. It's good. It's an important one. Okay, FOIL. X squared. This would be plus 6 minus 3, so plus 3x minus 18 plus 5 equals, this is a distributive property right here, 3x squared minus 12 plus 11x. Subtract over to the left side, we get negative 2x squared. Subtract 11, So then we get negative 8x, and add 12, we get negative 6 equals 0. And let's just multiply through by a negative 1/2. We can actually take out a 2, so switch all the signs and divide by 2, we get x squared plus 4x plus 3 is equal to 0. Now, we could start doing quadratic formula, but if I see this, I should see something else about this. I can actually factor that. That would be x plus 3 and x plus 1. So if you can factor it, don't do the quadratic formula. Factoring is a lot easier. This is x is equal to negative 3, x is equal to negative 1, and negative 3 and negative 1 are my solutions. I'll leave it up to you if you want to do the quadratic formula and prove that those are the solutions too. We're done.